okay now? I think it was Diana, my class representative, who said it cannot see. Are you able to see now? Shall I continue?
Yes, Doctor.
Okay. So first we will see what is coumarin, chemically how they look like, what it is. So coumarins are natural substance, one of the natural substance that is found in many plants. Okay, and they are fragrant chemical compound. Fragrant chemical compound. The coumarins, they have a particular characteristic smell, which is, when we say characteristic means this is the smell of coumarin only. You will see the smell only in coumarin. The smell is not related to any other smell. So they have a characteristic sweet smell. That's why they are known as organic, fragrant organic chemical. So if you see, we studied two other class of glycoside, that is flavonoids and anthocyanin. They are mainly responsible for color, providing color to different parts of the plant, whereas coumarin is responsible for a particular sweet smell. Okay, smell of new mown hay, the new grass. If you go to a field of grass, when the new grass grown, you will see, you can sense a kind of particular smell of the grass. That smell of grass is because of the presence of coumarin. And chemically, they belong to a class of benzopyrone chemical class. So if you look at the structure, do you remember something? This structure we discussed when we discussed the chapter flavonoid. Are you able to recall something? I am going to ask you some questions. Do you recall this structure? This structure reminds you what? Can anyone answer me? What do you recall from this structure? What are the other similar structure you studied?
Double bond.
Yes.
So it's one flav one. What?
Yeah. Continue. Try. If you remove the ketone.
Flavons.
Okay, you are nearby.
What exactly are we looking for?
Okay. If you remove this ketone group from the second position, what is the name of the structure?
Doctor, does it benzopyrone?
Flavon. No, مش flavon.
Yeah, you all are nearby. Yeah, this structure is known as benzopyrone. Okay, this is benzo 2-pyrone. Okay, so I'm giving you a clue. If you remove this keto group from the second position, what is the name of the structure? If you remove the keto group, yes.
Benzopyrone. 2H benzopyrone.
Pyrone or pyran?
Pyran.
Yeah, so remember you studied two class of pyran, 2H pyran and 4H pyran, right? So if you add ketone, it become 2 benzopyrone. If you add ketone at the fourth position, it become 4 benzopyrone, right? And if you, now I will go to the next slide. I prepared extra slide for you today, which is not there in your PDF. So look at this now. Is it clear? You see 2H pyran, when you add keto group, it become 2-pyrone. When you attach the 2-pyrone with a benzene ring, it become 1 benzopyrone 2-on or 2 benzopyrone, which is the basic chemical structure of coumarin. Whereas 4H pyran become 4-pyrone, and when you attach with the benzene ring, it become 4 benzopyrone. So 4 benzopyrone, it is the basic chemical structure of flavonoid. Do you remember or forget? All of you?
Yes, doctor, we remember.
Yeah, so why I'm asking this again in exam, which of the following scaffold represent, or this chemical structure belongs to which class of chemical compound, or the glycoside, flavonoid glycoside, coumarin glycoside. So you see, when this coumarin is attached with sugar molecule, it forms coumarin glycoside. When this flavonoid structure attached with the sugar molecule, it forms flavonoid glycoside. So see the main difference between flavonoid structure and coumarin. Flavonoids mainly derivative of 4 benzopyrone, where it is coumarin is 2 benzopyrone. But I would like to remind you, I have come across certain literature okay, which also claims that coumarin is a different class of flavonoid. Coumarin is part of flavonoid. Okay, you will also find this claim in certain literature, but you have no clear idea about the flavonoid, because when we say flavonoid, how we differentiate them? The flavonoid has C6, C3 and C6 structure. So that means it is bound to have another phenyl ring in flavonoids. Okay, even though you see both have only one difference, 2 benzopyrone and 4 benzopyrone. But another difference you will see in flavonoid, the presence of C6, another C6, which is not present in coumarin. Is it clear?
Yes.
Okay. So we go to, yeah, we go to next. So unfortunately, I'm not able to show you the what is that animation and slideshow because slide stucks in team. So we will continue like this. Coumarins, again, the name comes from the French term of the tonka bean. Bean means seeds, which is known as Caumaro. Caumaro is the name of a flowering plant. The botanical name is Dipteryx odorata, which belongs to the family Fabaceae. Coumarin was first isolated as a natural product in 1820. Okay, so you can see the picture of tonka bean here, from which the name originated. Now, regarding the significance of coumarin, you remember coumarins, okay, they are actually colorless crystalline substance in its tender state. It has a sweet characteristic odor, which is readily recognized as a scent of new mown hay. New mown hay means the new grass. Okay, there are many other different names given to coumarin because of this, because of its characteristic sweet odor. The other names are okay, like sweet woodruff, sweet grass, meadow sweets. These are the other names that are, that represent coumarin. Okay, because of the sweet smell. Now coming to another contrasting characteristic of coumarin. You see, they have sweet smell, but they have bitter taste. So coumarin tastes very bitter in high concentration in forage plant. So what is the purpose of this bitter taste? So although the bitter taste is to protect the plant, okay, or suppress the appetite of the predators, okay, or the cows when the new grass grow, it will have nice smell, and to prevent the cows and other cattle, from this thing eating those grass, the coumarins are actually produced in those grass as a appetite suppressant, which act as a defense chemical to discourage predation. So see two different characteristics: sweet smell but bitter taste. Right. This is one of the significance of coumarin. They discourage predation by suppressing the appetite. Now coming to another significance, so coumarin, some coumarins are phytoalexins. What is phytoalexin? I have no chance to ask you a question because you can already see here. We have studied in flavonoids already. Phytoalexin, which are synthesized de novo by the plant following infection by a bacterium or fungus. Phytoalexins, they are any group of compounds formed in plants in response to fungal infection, physical damage, chemical injury, or pathogenic process. So phytoalexin inhibit or destroy the invading agent to protect themselves, okay, from getting damage. Can I ask you a question here? Can you tell me the name of 2 or 3 examples of phytoalexins that you have studied in previous chapter? So, tell me who can answer. Phytoalexin. Which chapter you studied first of all? Phytoalexin. Who can answer? This is an important concept. Where did you study phytoalexin? What are the? Yeah. What is that?
Pencil was, I don't remember exactly.
Yeah. You can look back to your lecture note and you can answer. Yes, answer me. What is the name of the first phytoalexin that was discovered? I'm giving you the clue. And which plant it was discovered? I'm also giving you another clue. There is another phytoalexin we studied in previous chapters that can be used as a fish poison.
Have two names was
It becomes a residue on their, what do you call it? They cannot breathe the fish and they die. They prevent the oxygen. I think flavonoids.
Yeah, in the flavonoid. What is the name? 3 examples we studied. They are the derivatives of isoflavone. I have already given you the half answer. Yes. Flavonoid towards the end of the chapter we studied. What is the name of the plant where the first phytoalexin was discovered? Please answer. No one can answer? Okay. The first phytoalexin which was discovered in pea plant, what was the name?
I don't remember exactly. I can see like that.
Maybe it's the soybean, doctor.
Penis.
No, pea plant, in the pea plant.
Maybe it's the mung bean.
Psoralen. You remember Psoralen?
Psoralen.
Fish
Yeah,
poison.
What? Okay, I told you already the one example, Psoralen, which is an example of isoflavone. Okay, a derivative of isoflavone. What are the other 2 examples you studied?
Pterocarpans and retinol.
Rotenone and medicarpine. Okay, medicacarpine. Pterocarpine, under the pterocarpine, you studied 2 examples. That is Psoralen and medicacarpine. Okay, under pterocarpine. And then rotenone. Which one is used for the fish poisoning? No,
Retinol.
rotenone. Okay. So whenever we find some such common examples, common concept, we will try to recall. So when you recall this multiple times, you will never forget it when you go for your exams. All right. So we continue from here. Continue with the significance of coumarin. They are known as bitter principles because of their bitter taste. So coumarin is used in perfume since 1882 and also as a fabric conditioner because of their sweet smell. And as aroma enhancer, it is also used as aroma enhancer in pipe tobaccos and certain alcoholic drinks. All right, but its use is banned as a flavoring agent for food additives because they found to cause hepatotoxicity in various animal studies. So if I ask you, can you use coumarin as flavoring agent for as a food additive? Yes or no? If no, why?
It says that it has a liver toxicity effect.
Yeah, it says so. I also expect you to say the same. Yes. Yeah. So it cannot be, even though it has sweet smell, it is not used as a flavoring food additive because it shows hepatotoxicity. Okay. So next significance of coumarin. It was first synthesized in 1868, and it is mainly used in pharmaceutical industry as a precursor agent. Precursor agent for the synthesis of a number of pharmaceutical drugs and agents. Okay, two examples I give you here. The coumarins are used as a precursor for the synthesis of anticoagulant. You know the most common example, that is warfarin. Warfarin is synthesized from coumarin. It is also used for the synthesis of rodenticides. Remember this as a precursor. Again, when you go to exam, which of the following class or following is used as a precursor for the synthesis of warfarin? Next, although coumarin is widely distributed in plants, again here, some important point I need you to understand. We are studying, the chapter name is coumarin glycoside. And so far we have seen many types of glycoside, many classes of glycoside. Now, when it comes to coumarin, the special thing, 2 points you need to remember regarding the coumarin glycoside. 2 points, very important. First point, the glycosides of coumarins are very rare in nature. Okay, first point. Even though you find some glycosides, they do not have medicinal importance. These are the 2 points. Okay, so glycosides of coumarins are rare, and those which are present, they have less medicinal importance. So whatever medicinal effects you see, it is because of the egg glycon coumarin. It is because of the egg glycon, not because of the glycoside. So read now, although coumarins are widely distributed in plants, glycoside containing coumarin as such are rare. And several glycosides of, however, several glycosides of hydroxylated coumarin derivatives are available in the plant, but none of the hydroxylated coumarin glycoside is of medicinal importance. So very simple way to remember 2 points. Coumarin glycosides are rare, and those glycosides which are available as a coumarin glycoside, they do not have much medicinal importance. We will see 2 of the examples. Okay. One example is skimming. Skimming is an example of coumarin glycoside, which is available in Japanese star anise. You look at the plant structure of Japanese star anise. Okay. Second example is Eskalene. So Eskalene is also an example of coumarin glycoside, which is available in horse chestnut tree. It is mainly used in the pathological laboratory for the identification of bacteria. We will discuss in detail how this coumarin glycoside, Eskalene, is used in pathological laboratory for the identification of different types of bacteria. So before I continue, can I ask you to tell me a few keywords, the important keywords that you have studied about the coumarin? Then I'll ask you certain questions in the next slide.
It has a sweet smell but bitter taste.
Very good.
Should not be
Okay.
consumed because it has liver toxicity.
It cannot be, again, slowly.
Consume as a in the dietary should not be consumed.
Shouldn't be used as a flavoring agent.
Food additive.
Food additive, yeah. Should not be added as a food additive.
Okay, I take a break. You see, you cannot say should not be used as a flavoring agent.
Right, because it is
you can use it in alcohol. Yeah, see, you can use it in alcohol, tobacco, the pipe tobacco. Yes. So it is used as a flavor.
Additive, no.
No,
cannot use it as food additive.
Yes, because it causes hepatotoxicity. Okay,
precursor
the first
of
point precursor of
warfarin.
Yeah, pharmaceutical agent. Yeah, 2 examples we studied. Blood coagulant, that is anticoagulant, that is warfarin.
Precursor.
Warfarin. Yeah, it acts as a precursor for the synthesis of anticoagulant, that is warfarin. Okay, if you look at the structure of warfarin, do you see the structure of coumarin inside? Yes or no?
Yes. Yes. Yeah.
Only at the third position you see there is a substitution. At the fourth position you have a OH group. So it is a derivative of coumarin. Now you missed something at the beginning.
Also,
Structure
doctor,
is there. Yeah.
it acts as a factor of the self-defense for the plant, as it.
Yeah, phytoalexin. It is also an example of phytoalexin.
Yes, doctor.
How it provides self-defense, how it provides help plant to defense.
Bitter taste, through the bitter taste.
Better.
Mm.
Taste.
Decrease the
Yeah,
appetite of the predators.
exactly. By decreasing the, yes, providing the bitter taste, that means by decreasing the appetite, right? Very good.
Yes.
Now you missed one point, all of you, in the beginning that we studied in the first slide. Structurally they are what?
To the benzopyrone.
Flavonoid as part, no, yeah, as they're similar to flavonoid.
Is it benzopyrone or a
Benzopyrone.
benzopyrone? See, there are two types of
Benzopyrene.
benzopyrone. One is
Benzopyrene 2 on. Benzopyrene 2.
yes. Yeah, so we cannot, you see, there are two benzopyrone we have seen, right? Benzo 2-pyrone and 4-pyrone. So it is benzo 2-pyrone or 4-pyrone?
2.
Yes, it's 2-pyrone, right? And the benzo 4-pyrone, it is a part of which type of compound? 4-pyrone?
The flavonoids.
Yeah. Benzo 4-pyrone is a part of flavonoid. Benzo 2-pyrone is a part of coumarins, right? So is there any other point we missed so far? So first we know chemically what they are, then they have sweet odor, bitter taste, they are phytoalexin because of the bitter taste, they suppress the appetite, they are used in perfume, alcohol drinks, tobaccos, pipe tobaccos, okay, and also in fabric conditioner. You see the 4 uses. And also as precursor for the synthesis of different pharmaceutical drugs like anticoagulant, rodenticides, but they cannot be used as flavoring as a flavoring agent or flavoring food additives because they show hepatotoxicity. So these are the key points we have studied so far. And then when we started talking about the coumarin glycoside. So regarding coumarin glycoside, how many points I said to remember?
2.
Yeah.
Scamin and
Yes.
2.
Eco.
They are
What are
rare.
those? They are rare.
And the ones that
Rare, very good.
And the ones that are
Okay.
available do not have medicinal importance.
Very good. So coumarin glycosides are rare, and those which are available, they don't have medicinal importance. Okay. So how many examples of coumarin glycoside we studied, seen so far?
1.
Two.
2 examples,
Scamin
Scopoletin and Eskalene.
Skimine and
2.
Skimine, esculene.
Yes.
okay. Skimine is present where Japanese star anise, and esculene present in horse chestnut. How many of you remember? I did not write it in the slide. What is the use of esculene? Does it have any medicinal value? What is the use?
Glycoside, so no medicinal use.
Yeah, but I mentioned esculene has a use.
I can't remember.
It is used for what? It has a purpose. Esculene, what is the function, purpose of esculene? I explained also just now. Who can answer? It is not written in the slide. I mentioned. Let me see who remember.
I don't know.
What is the use of esculene? Who knows?
Vasoprotective.
No. Just now I explained.
I can't remember.
I give you that. It is used in pathological laboratory. For what purpose?
For bacteria.
For bacteria what?
Identification.
Yes. It is used in pathological laboratory for the identification of various types of bacteria. Okay, bacterial identification. How The mechanism of bacterial identification we will study in the next class. Okay, now we will move on to the next slide. Can you try to answer these questions? Which of the following drug is a derivative of coumarin?
Warfarin.
Okay,
Warfarin.
good. Which of the following coumarin glycoside is found in Japanese star anise?
Skimin.
Coumarin.
Skimin. Okay. Okay. Next, why coumarins are not used as food additives?
Liver toxicity.
Because of hepatotoxicity.
What is the option A, B, C, D?
B.
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 Option B, hepatotoxicity. Next one, how the presence of coumarin can discourage predation?
Appetite suppression.
Appetite suppression.
Yes, appetite
C.
suppression.
The option is C.